Okay, today is August 12th, 2025. I'm going to introduce you the paper second, mitigating perceptual hallucination in vision language model. It was ICML 2025 paper. Introduction. This is basically vision language model. A vision language model, they have three main missions or task. There's visual question answering, and there's image captioning, and there's open vocabulary semantic segmentation, and also so on, which is if input is basically image, and if you ask something, there should be output come out. The major problem is perceptual hallucination like other LLM does. Uh, when they see the picture and they say even there is no dog, they sometimes say there is a dog in this image. Then it's very problematic. What we are going to do is we will define the hallucination probability, which is defined by 1 minus p to the conditional probability of y and v and x, which is defined by probability of y, which is response based on the visual content and query for its just conditional probability. So if hallucination probability is higher, then it has more hallucination. So lower hallucination probability will be nice. And also in next page, there will be high visual attention concept come out. If visual attention and dice attention score increase, then hallucination score will be decreased. I will also introduce. Uh-huh.
In previous slide, there is a function
Mhm.
and how they calculate the probability of hallucination.
Oh, that's a very good question. Uh, it's basically defined by probability of 1 minus probability of response y, that is based on content and query. So it's basically remove the probability of language model is not answering based on vision and query. Is it understandable?
Somehow.
For L and T, the next phase, there is L and from T1 to they multiply everything. This is for each of the, I forgot the T, wait a minute. For each of the time or for each of the trinists, they multiply everything. But this is more intuitive. You are you are removing the probability of LLM will answer based on the visual content and query. This is the meaning. For this part, I will improve it and I will introduce you next time again. And there's also dice coefficient, attention coefficient come out. So what they want to measure is alignment between model's visual attention and ground truth object mark. So how well VLM focus on relevant object. So it will be calculated by uh, using Vision's encoder self attention map and the language model's cross attention map. There's correlation between attention dice coefficient and non-hallucination, and then what we can ask is how really the attention dice coefficient calculated, and or how can we increase the dice attention value? Uh, the answer is smaller patch size usually increase dice attention value when model attention aligns with object mask, providing theoretical justification. We introduced two major index evaluation metrics. Then now we will talk about how this second is organized. The mechanism is following. There will be multi-scale input, and we will do patch selection, and we will do contrastive decoding, and there will be refined output come out. First, multi-scale input is we will give variation on images resolution. If it is single scale image, then most of the model will be fixed to some pixels. But in this method, what they are doing is if models come in, then they vary the multi-scale, they vary the picture's resolution, which means uh, when human beings see the picture, or when human beings see the landscape, they so hold the image first, and secondly they focus on some area. That is the mechanism they applied. So they make first very low resolution picture, so make model to see the whole the pictures, and next time using patch selection they focus on some area and they make only focusing on some area and make high resolution relevant patch. And after that, we will do multi-stage decoding, which is uh, what was mm, and after multi-stage decoding, that there will be output will be come out. So multi-scale visual processing, as I mentioned, uh, the model will create scale-aware visual representation by downsampling and change the image resolution, and the grid of patch also changes. Then problem is the grid of patches are changing. So usually what after multi-scale visual processing, what other models do is encoders to learn new positional embedding for those new grid size, because there's picture like width and height, but because of low resolution, width and height is changed to divided by 4 and divided by 4. Then actually what other models do is by new positional embedding, they learn new grid size. But in this model, what they do is by bilinear interpolation on the original positional embedding, they just estimate the um, position. So it will be computationally efficient. And after that, we will do selective mechanism, which is select object relevant patch based on visual obtention map from previous stage. So from previous stage, we will find focusing on important reason by important by attention process. And after that, we will calculate entropy. If higher entropy, then more patch is selected. And after that, we will do contrastive decoding, which is when we see the transformer, the last layer is logit layer, which is softmax layer. So give the highest probability and so on. But we will do additional operation on contrastive decoding to make better output. So yeah, this is contrastive decoding step. There is logit, but we are we are very we are giving more operation on logit. We are not just giving the output directly by one logit, but they are uh, stage 4 will be probably better than stage 1. So they kind of do the average weighted sum. On logit expert, they will give biggest one, and also in other stage output, they do weighted sum. So this is experimental setup. Mhm.
You mean that stage one to four is the multi-stage that all process is included in multi-stage contrastive decoding.
Right. But it is multi-stage contrastive decoding. But basically, for stage first is that we used the patch with low resolution. And if you go to stage two and stage three and stage four, if if you go to the stage on the backward side, they use high resolution input. So like I said before,
What high resolution
uh,
included?
because in multi-scale patch selection process, what I said is like what humans do when humans see some landscape over there, they feel hold the overview first, and they see very particular parts next. This is kind of that mechanism. When we put the input image on this model makes it to low model lowers the resolution of the image. So at the first stage, they will see the very lower resolution of the image. And after from that one, we will calculate the attention metrics. So we will focus on more important thing. And for more important thing, we will high up the resolution. So in stage two, we will for only some specific part, we will use more better resolution. And if you go to next step, then we will use high resolution for some step. It's iteratively refined process. And in multi-stage contrastive decoding, we will just decode each of the encoded result. Then in each for each stage, stage four will be there will be more dense and fine-grained, high-resolution or visual information will be exist here. And for stage one, there will be only low resolution or visual or information will be there. Yeah, so this is the just benchmark uh, second that outperforms other model. And this is ablation studies and analysis. So uh, their patch selection was, if you see the F1 score, it was nice. And this is robust demonstration. So mm I will give you more detail later because I didn't finish this slide. But basically, like they tested like uh, giving the image with more difficult situation and asking, is there a tennis racket in the image? Or where, what is the sum of the digit on the sign in the corner? Like this kind of things. They successfully, I think they successfully answered, or maybe some problem was here. I will give you more information later. And so key contribution is first, it is training free framework. Like they just use bilinear interpolation, not using another encoder to to know the position. And they did multi-stage contrastive decoding and selective patch integration. Based on this, their empirical performance was nice. Thank you. Is there any questions that you have in this slide? We'll then first finish the presentation. Thank you.